Today we are going to discuss about the SHA algorithm. So likewise we have discussed the algorithms regarding the confidentiality. So in confidentiality we have discussed about the DES algorithm, AES algorithm, which comes under the symmetric encryption, and in the asymmetric encryption we have discussed about the RS algorithm. Likewise we are going to discuss about the authentication algorithm. So one of the algorithm is SHA. So let us see the SHA algorithm introduction. So most widely used hash function, and it is developed by the NIST, and there are different versions of SHA. So SHA-1, SHA-256, 512, 224 versions are there. So we have the message digest. So in SHA-1 we are going to use the message as 160. In 224 we are going to use 224. 256 we are going to use 256. In 384 we are going to use 384. In 512, 512 bits. So the word size is 512 here in SHA-1, 224 and 256, and 1024 in 512 and 384. So word size is 34 until 256, and 384 and 512 are 64. So number of steps also depends upon the algorithm that we are going to use. So today we are going to see how the SHA-512 works. So SHA-512 is a version of SHA with 512 number of message digest, and it is based on the Markov dam guard scheme. So we are going to discuss the topics, that is introduction, compression function and analysis. So coming to the introduction of the SHA-512, so you can see here in the block diagram, we are taking the number of blocks. Each block should contain of 1024 bits. So these 1024 bits are given to the compression function, and we are going to take the initial value and apply it, or initial vector we are going to apply to the compression function, and the output from the compression function will be given to the next compression function. So like that we are going to get, and we are going to get the message digest. So initially we don't have the previous function result, so we are going to use the initial vector, and these 1024 bits are again divided into further, that is 1024 bits will have the of length. Suppose if a block size you have a plain text of more than 1024 bits, then we are going to divide into two blocks, that is 1024 blocks can be done. So the process of these sharp steps we are going to see. The first step is append the padding bits, then appended length, then initialize the hash buffers, then process the message in 1024 bit blocks and find out the output. So whenever you are taking the step 1 and step 2, which is called as message preparation, so 512 bits insists that the length of the original message should be of 128 bit. So the message bits, so the plain text bit is 128 bit, and we are going to take apart from, that is 1024 bits, we are going to have 128 bit we are going to take as the plain text, and all other 1024s, and other than the 128 till 1024 we are going to pad the bits. So we are going to create 512 number of message digest out of the 128. So let us see the how the step 1 goes, step 1 and 2. So we are going to take the length of the message as 128 bit. This is the original message what we are going to take, the plain text. Then we are going to pad the value with first value with 1 and all others with zeros till the length of the multiple, it should be the multiple of 1024. So the length of this original message should be of 128, and other odds should be padding values of 1024 bits. And we need to pad the values to the left of the values, not onto the right side. So the number of padding of bits length is original messages. Suppose if you have 2590 bits, then we are calculating the bits as follows. Then we are going to get as 354 bits of padding of zeros. So 1 followed by 353 as zeros. Similarly, you can see another example. Do we need to pad if the length of the original message is already 1024? Yes, we do, because we need to add the length field, that is the original bits are to be added with 128. So 128 bits, then we are going to take the padding values as other than the 128. So we need to pad is needed to make the new block of multiple of 1024 bits. Then what is the minimum and maximum number of padding bits that can be added to the message? So the minimum length of the padding is 0, and it happens only if you have 128 mod 1024, that is 0. This means the message is minus 128 mod, that is 896 mod 1024 bits. So in the last block, if you have the original data is 896 bits, we add 128 bit length field to make the complete block. So the maximum length of the padding should be 1023, and if we cannot just add the length of the field, because the length of the block exceeds one more 1024, so we need to add 897 bits to complete the block, or create the second block with 896 bits. So this been added to block the complete data. So the message digest initialization. So the initial vectors, we have the A0, B0, we have the 8 vectors where 1024 bits are divided into 8 buffers. So these 8 buffers values are having the hexadecimal. These are already have the initial vector values. So like I said, we are going to have, initially we don't have any of the previous values. So we are going to take the initial values. So these are the initial values that we are going to put into the 8 buffers. So once the values are calculated, the first 8 prime numbers are these. So each value of the fraction of the square root of the corresponding prime number after converting to the binary, keeping first to the 64 bit. For example, if we are converting the 19 power 1 by 2, this is the value which can be changed into the hexadecimal value. Then coming to the words, so the message block, in the step 4 we need to convert the block or the digest as the words. So how we are going to take the words? Words are nothing but the 8 number of buffers what we are taking. So these buffers are got from the 16 words. So how these words are built? By taking our original message only, that is 1024 bits we are going to take. So using those 1024, we are going to build our 16 words from that. So how we are going to do? We are going to see. So we have 8 buffers. Each contains how many bits? 64 bits. So totally we have 512 number of bits. So word expansion is done in this fashion. So first 15 words, first 16 words we are going to get, since each word contains 64 bits. So first 16 words is taken from the original plain text. From the original plain text, that is 128 bit padded with ones and zeros. That 1024 block is again divided to each 64 bit. So each word becomes, so we are getting how many bits? See how many words? 16 words we are getting. From this 0 to 15. From 16th word we need to do the calculation. How we are going to perform the calculation to attain the words? So this is the formula. That is, we are going to shift the algorithms 1mn, that is 1 here if it is here. So we are going to take 187 word of I minus 15. So here this is the formula that we are going to use, and we are going to achieve 79 words. So how many round compression functions we need to do? 80 rounds. So we are going to achieve 80 words. So word 60 is made. So each word range from word 16 to word 79 is made from 4 previous made words. So word 60 is made as, so 60 is equal to word 44 plus the rotation, that is circular rotation shift of 187, then of word 45, and XOR with the word 53, XOR with again circular right shift of the 1961 6 bits, that is 19th bit, 61 bit, 6 of word 58. So like that we are going to do. So once you have got, we are going to put into word 60. So this is the compression function block diagram. So we are going to take the message. From this message 1024, we are going to build how many words? 80 words. For each round we are going to give the words, and we are going to take the initial values of 1024, the initial vector already predefined, so those are divided into 8 buffers. So these 8 buffers are A, B, C, D to H. So each contains of 64 bit, and at the each round we are going to apply the key, and this key is also of 64 bit. So like that we are going to apply till the 79 rounds. Once you apply the 79 rounds, then we are going to take the initial vector values and XOR with the output values that we come under the 80 round. So once these 80 rounds are finished, the output values are XORed with the initial vector values, then we are going to take as a message digest. So these are the 80 constant rounds that we are going to have, 80 keys. So at the each key value we are going to have these constant keys only. So there are 80 constant, that is K0 to K79, each of 64 bits, and these values are calculated from 80 prime numbers. For example, 80th prime number is 409, which is a cubic of. So like this we are going to calculate, and this value we are going to put into the hexadecimal value. So like this we are going to convert them into binary, then we are going to convert them into the hexadecimal value. So in the round function, so we have got the round function. So in the compression function we are going to do the round function. So in the buffers, when we do the round function, those round function contains these values, that is we have certain formulas. So that is nothing but we are in the 8 buffers we are going to have these formulae. So this is the formula we are going to put. So H plus, H is the buffer, plus the circular shift of E, F, G. Circular shift of E, F, G. Then we have sigma of 1 to 512 of E plus the WT values and KT values, and 0 to sigma of 0 to 512A and majority of ABC. So the G buffer is again given to the H, F buffer is assigned to G, E buffer is assigned to F, and D buffer plus T1 is assigned to E, then C buffer is assigned to D in the next round. Once you calculate this, apply this, then in the next round you need to do all this formula. Then B block, the B buffer is applied to C, A buffer is applied to B, then A will contain T1 and T2, T1 plus T2, that is additive value of T1 plus T2. So like this. So in the previous we are going to see, so CH like this, the circular shift of these three values, then XORed with H, Then E, we are going to do the summation 0 to 512, then XOR. Then we are going to get word T, that is word values. At the each round we are going to apply word value. So this word value and also the key value of that particular round. This is the key value. Now, these majority values of the formula we are going to apply. Then we are going to summate and we are going to XOR. So this plus symbolize the XOR function and we are going to apply all this in this manner for next round function. And you are going to use these formulae. So these are CHEF is a E and F XORed with not E and G. So when you are doing the conditional function, so in this E and F, E buffer and F buffer. So we are doing the AND operation XORed with not E, that is negation of E buffer. If it is zeros are there, we are going to change them into 1. If ones are there, we are going to change with 0. Then we are going to apply the AND operation, then G. So the conditional functions of E, then F and else G. Then we are going to get the majority values like A and B. So A and operation B XORed with A and operation C XORed with B and operation C. Then these values, we have got the sigma values, that is circular right shift of the 28 bits of A XORed with circular right shift of 34 bits of A plus XOR with 39 of A. Like this we are going to take the shift. Here also similarly E rotation circular right shift E XORed with circular right shift of 18 E and circular right shift of 41. Then WT is the word derived from the current 512 bits input and KT is the additive constant. The additive constant are the key constants that we have from 0 to 79. Then plus symbolize the addition model of 64. So once you apply, so the majority functions how we are going to apply. If you are applying for ABC, so if both 0, 1, 1, the majority is 1. If it is 1, 0, 1, the majority is 1. If 1, 1, 1, majority is 1. If 1, 0, 0, the majority is 0. Similarly, when you are applying conditional functions, so in conditional functions, you can check the values for the first bit are 1, 1, 1. The result of F1 is 1. 0, 0, 1, the condition which is nothing but 1. If it is 1, 0, 1, 1, the condition is also 1. So if it is 1, 0, 1, the resultant is 0. So with message digest of 512 bits, SHA-512 is expected to be resistant to all attacks including collision attacks. And we are going to see the block diagram. So at the each round we are going to apply like this. And we are going to take ABC majority and rotate the A XORed and we are going to apply it to X. Then EFG conditional function, then rotating E, then XORing, then applying the word and also key, then giving to D. And again this particular functions are being A is given to B, B is given to C, C is given to D, E is given to F, F and given to G, G is given to H. Now H value, that is value is given to, is seen as a Y. So E value is given over here and A value as X. So like this the operation. Thank you.